So we'll do a couple quick basic examples that follow this set of rules, and you should be able to comfortably do at least half of the equations in the homework. Okay? You can find more examples in the textbook. Push yourself. The more you can come in comfortable with this before I see you on Tuesday, the better. Okay? So, to get you started, very basic one, let's say square root of 4x is equal to 2. Is that radical isolated? There's nothing added or subtracted to it. There's no coefficient. So we're ready to power up both sides. If we want to get rid of a square root, what do we do to both sides? Sorry? Oh, no, don't overcomplicate this. The power rule says raise both sides to the same power. Okay? So we're going to put the left-hand side in parentheses, and to cancel out a square root, we square. Yeah. If this were a cube root, we'd cube it. If it were a fourth root, we'd fourth it. Because the power cancels out the index. When they match, it's going to kill the radical. Right? It's the 2 and the 2 are going to obliterate that radical sign. It's going to release the radicand. Right? So be fair to both sides. Put the whole right-hand side in parentheses and square it. And that's a fair rule. That's the power rule. It's a fair rule. In doing so, you kill that radical. And once that radical is dead, that obliterates the radical, releases the radicand. And over here, it's just a number, so we square it. We have a resulting linear equation, so we'll have one solution. So just solve with your linear general strategy. Now, some of these are really easy to test mentally, and others I'll review. The last one I do, I'll show you and remind you in the calculator how to do it. You always go back to the original equation. Yes, this is the solution to this linear equation, but is it a good solution for the original? Well, if x is 1, that means 4 times 1 is 4, and the square root of 4 is 2. Check. It balances, it satisfies the equation. So put your solution set in set notation, and go. So I know these are a little rushed, but I want to give you sort of a variety of things to look for as you try them yourselves and move forward. So we've got that one. Square root of 3x equals negative 6. And then also square root of 5x plus 6 plus 2 equals 8. Check that it is isolated. If so, power up both sides. It is isolated. There's a plus 1, but it's under the radical sign. So that's good. There's nothing outside the radical sign on the left. No coefficient and nothing added outside the radical. It's an index of 2, so we cancel that out with a square. That kills the radical, releasing the radicand, the intact radicand. We're left with a basic linear. Solve for x. If x is 48, that makes this 48 plus 1, or 49, and the square root of 49 is 7. Check. Good solution. Now, if you had one solution and it was bad, your answer would be null. No solution, or the null sign. Okay. So are you busy powering this one up? Stop for a sec. I want you to think logically about this. When you square root a number, will you ever get a negative answer? No. Huh? Yes, there is a negative square root. Remember, we introduced that at the beginning, but for it to have a negative square root, it has to tell you specifically we want a negative square root. In general, we assume a positive square root. The principal or positive square root. So if you have square root equals a negative number, stop. Now if you go ahead and solve this, you would have 3x equals 36, right? Because you power up both sides, square both sides, you get 3x equals power this, negative 6 squared is 36. 3x equals 36, so x would equal 12. Now we plug 12 in here, and what is 3 times 12? 36. Square root of 36 is 6. So if you miss this and go ahead and do it, you're going to, as long as you're checking your work, you'll see, oh, that's bad. Because we assume, unless we're told otherwise, if there's no negative in front of here, we assume the positive or principal square root. So there is no way, even plugging in that 12, that we would get a negative 6. The answer would have to be 6. That would be a bad solution. But if you recognize that to begin with, square root cannot be negative, no solution, move on. Save yourself some time. Now what if this were a cube root? Yeah, that was no problem. Cube roots, any odd indices, negative radicands, negative answers, totally legal. Yeah, that happens. Okay? But any square or even index must be equal to a positive number. Cubes or other odds, negatives are free game. Now you can't make that decision though until you are all isolated. Nothing but the radical on the left and the number whatever else there is on the right. Okay? Now if you have a negative number over here but there's also an x, then you wouldn't say null because the x might change things. But right now it's just a number. If it's just a number and it's negative, that's not possible. And we are going to, especially you'll see some in the homework, and especially on Tuesday we'll look at some where we have x's on the other side too. Okay? We cannot make a decision about whether this is good or not until we do what?
Isolate.
Yeah. We're not ready to power up, and we can't even decide if it's good or not until we isolate, because sometimes this might look negative, but when you move things over, it becomes positive. Or vice versa, it might become negative and you throw it out. Okay? So isolate is the very important first step. So there's no coefficient. I'm just going to take care of the addition property here. Square root of 5x plus 6. Minus 2 on both sides. If I had a coefficient here, I would then divide it away. Like if there were a 2 here, I divide both sides by 2, and then this would be equal to 3. Okay. I think there's one like that in the homework. Okay. But now you check, okay, that's positive, square root, and that's positive, so we're good to go. It's isolated. Power up both sides. That releases the radicand intact. Resulted in a linear. Solve for x. Okay. So let me remind you now about how to use the calculator check, and that will send us off on this. Okay. So any questions about solving this, about getting to x to equal 6? Isolate first, power up both sides, power to match the index, releases the radicand, see if you have linear or quadratic, solve accordingly. Now we want to see if x is a good solution or an extraneous. X is right now is called a proposed solution. We have to check that it is a good solution, it's proposed, and we'll see if it's good or not, or whether we have to clear it out. Now remember on your calculator, the easiest way to do this, especially with these more complex looking ones, is to use the store button, which is right above the on key. Okay? So I want to test 6. So I do 6. I push the store button down the bottom left here above the on key. And when you push the store button, it gives you an arrow because the calculator is saying where should I put it. And you just tell it X, no matter what letter it is, just put it in X. And you push enter to verify. And the calculator says, okay, anytime you say X now, I'm going to insert a 6. So that's going to insert 6 into this, and it's going to tell you whether it's true and satisfied or false. Remember, the calculator doesn't say true or false, it uses binary code. It's going to return either a 0 or a 1. 0 means false, 1 means true. 0 and 1 doesn't mean that's the solutions. Those are not number solutions. 0 means true, 0 means false, 1 means true. Okay? When you use the test button, you're looking for a true or false answer. So you go back all the way to the original equation. This doesn't do you any good. You know this is a good solution for that linear, but it's a proposed solution to the original. So enter the original just like you see it. Do second square root 5x plus 6. Now this is very important. Don't be lazy about this. There's something outside this radical sign. That plus 2 is not under the radical, right? If you put it under the radical, it changes everything. That parenthesis, when you do square root, it opens with a parenthesis. You tell the calculator you're done with the radical by closing the parenthesis. If you don't close that parenthesis and then you just put in +2, it's going to think that belongs under the radical, and that changes things. Okay? Now, if you have math script, it might just be a blinking cursor and use the arrow to pop out of it. It'll look a little different. If you're not sure, just ask me after class. So I enter just what I see. 5x plus 6 is under the radical, close the parenthesis, +2, and then I need my equal sign. So that's where I go to my test button. Second math is my test, and I'm just using the equal sign, just push enter. It's number 1. And on the right-hand side, I have an 8. And when I push enter, I will get true or false. And I got true. Doesn't mean the solution is 1. That 1 means, when I'm testing, that means true. This is the proposed solution is a good solution. It is not extraneous. And so, I'm done. Okay.
Instead of doing the last part equals 8, can you just put in the equation and set it enter?
Yes. And because that 8 is so simple, if you didn't want to do the test button, you would just enter that, push enter, and if it equals 8, you're good. The only reason I show the test button is sometimes both sides are pretty ugly. If there's variables on both sides, the test button's very useful. If there's just a number on one side, you don't really need the test button. That's a good observation. Yeah. Because if there's variables on the other side, you have to enter the left, push enter, then enter the right, push enter, and make sure they match. So. Okay, thanks, you too. Remember, there's no lab today, but I am available via email, so let's work ahead in your homework and let me know if you have any questions. Great weekend.